So today we're going to talk about privacy engineering. And to explain a little bit why I'm interested on this topic, this is a screenshot of one of the screens of my phone as of 2 days ago. And if you look at it, you can see that it has information about almost everything I do. Like my leisure time, what kind of movies I like, the music, a lot of things about my doctor appointments, news, banking, kind of a lot of information. And everything that is not here is actually in this little icon where I'll do all of my web browsing and email. So even though each of these things, well, they kind of know one aspect of me, if we think about all of the information that is here, the digital world soon becomes the Eye of Sauron that can see everything we do. But if you have read The Lord of the Rings, you will know that while we always kind of portray this thing as very bad, what was really bad was the fact that Sauron could not only see, has the ring to dominate them all. And this is what can happen when somebody knows a lot of information about us. It starts to be something that allows them to manipulate us, to influence us, to interfere in our lives. And this is what happens with these applications. And one that really blew my mind when I started reading about this, because probably also you have not thought about it, is Spotify. It's just music, right? It's the music that we hear. It turns out that the Spotify is actually kind of rivaling Facebook and Google in terms of ads, because they have much more interesting data than them. It turns out that the music that we listen to actually says a lot about our moods, what we're doing, when we're doing it, when we go running, when we're sad, right? Like last weekend, we know our neighbor is very sad. She's kind of around 15 years old, and she was the whole weekend listening to Laura Pausini, like full volume, like imagine what happened, right? I'm also sure that Spotify knows that we have a little one, given the amount of Disney songs that play in our list. And this they can use actually to do ads, and this is their own page where they say that they are kind of one of the most accurate if you really want to go for this, and for this kind of very punctual thing that will get you the money. And okay, we may say, okay, well, advertising, you know, yeah, we live in a world of advertising, but what do we care? But when we start having a lot of this information, it starts to turn into things that we may care more about than, well, what am I going to buy next weekend, which is our democracy. And if you may remember the case of Cambridge Analytica, where this company got a bunch of kind of innocuous information from Facebook, like likes from people and where they live, and they turned this into super powerful information to give very targeted ads that ended up with Donald Trump being president, and 4 years down the line that ended up with guys with horns storming the Capitol and causing a crisis of a democracy that we wouldn't have imagined before. So everybody realized of this, and already back in 2010, our policymakers were thinking like, okay, we're digitalizing, all of this trove of information is there, we need to do something, and they started creating regulations and policies to do this. Here we have Canada, the European Union, or the United States, and their main regulations on privacy kind of saying we need to have good privacy protections, privacy by design, companies should have privacy protections, data security, and all of this is great, and I guess that if I ask one of you, you would say, yes, I want this thing, but also many of you computer scientists, and if I tell you, okay, how do we build this thing, it more or less looks like this. So I have spent the last, well, more than 10 years already thinking about how do we get from these circles to actually the all? How do we create these things? How can we explain it to other people? How can we kind of scale from maybe a bunch of PhD students that can create some of this system in a way that we can create engineers that can actually build the world in which we would love to live? And back in 2010, when this thing started, and I was working with some colleagues in Leuven, we said like, okay, privacy is about data minimization, right? And everybody can agree with this thing. We want systems that don't have data. They don't have data, the less data in the system, the more privacy. And it was great because everybody can agree with this. It sounds super intuitive. It's also related to a legal principle in the data protection regulation, so policymakers were all about this thing. In fact, they gave us an award. It was all very nice. It was 2017. I just arrived to EPFL. The dean was super happy. I was on the news. All was great. And then we started working on this thing, and we realized that this was a bluff. It was absolutely not true. Because when we build the system, not when we kind of think about where the data goes, when we build the system, the data is still there. We can have it in the user's devices, we can encrypt it at the server, we can distribute it, but the data is there. It's not about minimizing the amount of data. We cannot build the system without it. It's about something else. So data minimization is actually a very bad metaphor. And when you try to explain to someone how to build systems, you cannot go in this direction because they're not going to know what to do. They're going to be like, I have the data. I need to compute on it. What is this thing that you're telling me I cannot have data? So we went back to the drawing board and we thought about what is it? What is it that in the literature of privacy research we build? And then we discovered that it is about trust minimization. What we want to do is not about not having data, it's systems in which we don't need to trust the provider, the service provider, like Spotify before or Facebook, with the data. Yeah? And to do this, we may not send the data, kind of compute locally, and then they don't have any access and they cannot do anything with it. Or we can do very advanced privacy-preserving encryption mechanisms that allow me to build things, anonymization, obfuscation, and these things like lately have taken off in the form of privacy-preserving machine learning, in which now everything is thriving, and actually privacy technologies are at the kind of the top of the wave because we can enable privacy technologies. That's okay, because now my work here is done. It's cool. I mean, not cool because I didn't have tenure back then, but so I needed to do something else. It was okay, but I was like, okay, we got it. But then I started to think again, right? Came 2020, and we had these contact tracing apps and et cetera. And why are we doing this? Why are we doing privacy? And if we go back to the heart of the thing, of this fundamental right, right, the thing that we always say, well, we want privacy, privacy is a fundamental right, we need to live with it. If you go back to the Universal Declaration of Human Rights, it doesn't say, and this Article 12 is typically called the right to privacy, it doesn't say we want privacy. It says no one shall be subjected to arbitrary interference. As I said before, the problem is not the eye of Sauron. That is, I mean, that's a problem. Nobody likes to have the eye of Sauron looking at you. But the problem is the ring. The problem is the interference. So the question here is that minimizing trust does not necessarily minimize the harm or the capability of interfere or of doing attacks. In the case of privacy-preserving machine learning, if we do and train the same model in a privacy-preserving way, it does not necessarily mean that we have solved the problem. Let's take the two examples that I had before. Spotify. Imagine that the Spotify, instead of, well, doing a streaming like we have nowadays, we actually would build it with super strong privacy technologies on it. And instead of searching songs just like as we do now, we would use private information retrieval, so the server doesn't know which song I'm playing. But they could still kind of train all of their models for advertising using the latest multi-party computation. And then they could serve me exactly the same ads. Would that be a difference for me? Or in the case of Cambridge Analytica, imagine that Cambridge Analytica, instead of stealing all of this data from Facebook, would actually use the latest homomorphic encryption and differential privacy and would have trained exactly the same models without seeing the data. Would we be happy? Would we actually say that democracy was saved? We would have exactly the same problem. So it's not because we don't trust the server with the data that we actually have to solve the problem. It is not it. It is not the way of thinking about it. It is not sufficient. And all of this time, I have always talked about what the server can do. And that is what we call the purpose of the system. Actually, building privacy-preserving systems is not about not touching the data. It's about making something in which we can control the uses of the data, in which we can say, well, I want to enter the system for this particular reason, maybe listen to music, but I cannot have any other purpose. And to do that, what we should do is to identify the minimal set of data that allows me to do this purpose. And no worries, in a second, this will become more clear. And then we can build a system that achieves the purpose that we want, in this case, kind of listening to music, minimizing the possibilities of reusing this data in such a way that it cannot be used against me in ways that I did not desire. And for that, we use what we call privacy-enhancing technologies, which are all of these fancy names that just said, like homomorphic encryption, multi-party computation, differential privacy, and many other techniques that allow us to actually operate on data. But again, the goal is not to hide the data. The goal is to limit what you can do with the data and what do we trust the server for. It is true that full protection may always not be possible. It may be that this minimal data is enough data to do a lot of things. And this is something that in the beginning stressed me a lot because we could not fully protect people until I came to the realization, well, then so be it. Right? But the main difference is that when we think in this way, we will actually realize which other purposes we have, and then we accept or not accept whether this is good for society. We accept or not accept whether this is acceptable to train models that can influence people on elections or not. And that's what we should do, but making explicit which are the purposes that a particular design, application, or system allows us to do. So purpose limitation is actually a very good metaphor to conceptualize what this means to do privacy protection. And every time we design a system with privacy in mind, we should be thinking about this purpose much more than about the data. We cannot be blind by the data because then we will miss the main root of harm. The good thing is that this is also related to a legal principle. It's also in the data protection regulation, and it may be that one day I write this actually on a paper and they give me another award. We'll see about that. Rudy is also going to be very happy about that. So how do we do this? Why is this actually possible to do this thing of minimization? So let me go through a bunch of examples, and one of them is a collaboration that we have with the International Committee of the Red Cross, here present, represented by Vincent. And the problem that they came to us with is that, I mean, they want to help people, but they don't have infinite money. They actually have quite limited results, and there is a lot of people in the world that they would like to help. And the thing is, how can we maximize the number of people we help? Is by distributing as better as we can, and that means that I should try to not distribute twice to the same people. Right? So the problem that we have is we want to make sure that we give as many people as possible, and people cannot come and kind of take more than what they would be entitled. And traditionally, they solve this problem using this very advanced technology called pen and paper. So in an aid distribution scenario, people would go, the Red Cross staff would go with aid, people would come, take the aid, and then they would sign on a paper, I came in November here, and I took my things. So they cannot come twice because the name is already scratched on this list. But this does not scale very well. Kind of doing this thing is slow, and sometimes it's very important for a Red Cross to do this very fast. Imagine in a conflict situation, which you will have a lot of people in a dangerous place. You don't want to have them for hours while you search for names on a page. It is easy to manipulate. I mean, come on, this is a paper and pen. It's not very hard to falsify or do anything, and therefore it is hard to audit. Also, to audit, you need to have all of this bunch of paper that come from a place in the middle of Africa, for instance, and you need to ship it to one of the headquarters of the Red Cross. And this is hard. So they came to us and said, can we do better digitalizing? And the question here is very important in this scenario, is can we do this without increasing the risk? Can we do this without enabling new harms that were not possible before when we only had paper? And then we spent the first months just working with them, trying to understand what's the problem that we're trying to solve, and how does this humanitarian aid system works. And in the first step, what happens is that when a person wants to register, they go and they register into what we call a registration station. And typically, they register by household. It's not normal that you register per person, but it's a household that has kids, that has maybe elderly, and that would tell which kind of aid you're entitled for. So the registration station will check that you are actually a person that needs the aid, and will tell you how much aid you have, and will note that down. And then when you go to distribution, you will again say, well, I'm the person that comes from the family one here, and then, okay, you're on the list. In the list, it says that I should give you 3 bags of rice and 1 formula. I'm going to note that for November, you came here, and can you please sign so that we can make sure that we don't give this to you again. And then at the end, when you want to audit, well, you will give a full list of all of the signatures as before, and then the auditor will check that actually all of the signatures there more or less correspond to what was in the warehouse, and everybody's going to be happy. And the question here is, how do we digitalize? And of course, straightforward would be like, I mean, come on, is this even a problem? We just put everything here on a database, right, that everybody kind of can access and connect, and we're done. And we just remove signatures by something very digital like biometrics, and then the problem is solved, right? You can even put this in a blockchain if you're very much into wasting resources. It will all work. Yeah, it's going to be great. And this is true. This is easy, right? We know how to do this. But the question here is that if we create a central database, we can scale, we can make this very fast, but we cannot prevent abuse of the data. Because now we are going to have here biometrics, a lot of information of who went where, when, and it is not us that said this thing. It has been shown many times that when you create this kind of data, something bad is going to happen, right? So in Yemen, the World Food Program tried to use biometrics, and then the Yemeni authorities decided that this was a very useful data set because now you have biometrics, which is kind of an identity, a digital identity, and they could use it to actually find some of the different races and ethnias, some ones that maybe the government doesn't like very much, and it was a huge problem for the program. We also had when the Afghans took when the Taliban took control of Afghanistan, like last year, we also had evidence that now they took over a lot of biometric databases that actually Western companies had created there because, just digitalization is good for you guys. And then they were using it or potentially using it to actually kind of target refugees or people that were flying the country as they were getting into power. So our solution is we don't create a database. Creating a database is a bad idea because then we need to trust the database to keep this data. And we cannot only trust, maybe you can be coerced by a government, maybe you have to flee the country and leave your computer there, and all of this is not a very good idea. And to make sure that the rest of the system works, we're going to use these pets and a lot of cryptography to make sure that we can make the system secure. And how this works is when you go to the registration station and you say, okay, Boya for house 1, you will receive a card. And inside this card, this is a smart card, so this is inside this chip very securely. The thing that's special that you will receive is a key, a cryptographic key that is unique to your household. And also inside the card, we will put a biometric. But there is not a database of biometrics. There is one biometric in every card only for the owner. And whenever you go to the distribution station, the first thing that you will do is to authenticate yourself towards the card. So if you are the person and the card believes that you're the person because you match the biometrics, it will spit to the distribution station your entitlement. Okay? So like this, we make sure that only in this case, only Boya can actually go and ask for the entitlement. But now we wanted other properties. We wanted this to not be used a couple of times. And how do we do that? We use our secret here, this key of the house, and we use a cryptographic function that whenever takes a key and a constant value, in this case the period 5, let's say November, it always outputs the same, what we call a tag. So we take, the card will just compute this tag and give it to the distribution station that will note it in the database. And if I come back within the same period, and I try to again convince them, okay, my card will actually spit something because it will be my biometric, but when the tag comes out, because we're in the same period, it will output the same tag, and then if it was already on the data set, it's going to say, no, I'm sorry, we already gave you this data. And to help with the audits, we use 2 other techniques. We use signatures, very normal digital signatures, in which the cards sign everything that comes out of them, and we also put this on the database. And if signatures are correct, it means that you always had a card. You always had a legitimate recipient actually in front of you when you distributed the aid. You can also check the tags, as we said before, and if they are not duplicates, it means that nobody went twice. And we also add this other row, which is called a commitment. And a commitment is a cryptographic tool that allows you to kind of encapsulate a particular value. And what we encapsulate is the entitlement. So we make the card in a privacy-preserving way to spit how much did it tell the distribution station to give out. And then at the end, we can make sure, using some cryptographic computation, that the sum of the entitlements that the distribution station claimed to have given is equal to the sum of the entitlements that the cards have asked for. And in this way, the auditor can be sure that all of the aid was asked for by legitimate recipients. So the distribution station could have not invented records and just give aid at random, because they would need to have a proof that somebody with a card was in front of them actually asking for this aid. And kind of the magic of this thing is that this table that we have at the very end is useless for nothing else that is exactly the things that I just said. You just have a bunch of random numbers. Here are small. In reality, they're a bit bigger. And you just cannot do anything with them, right? They don't give you information about who was there, when did they come, how often they came. You just don't know anything. You don't even know, if you just know nothing about it. And this way, we just can make sure that this data set can be there at the registration desk. It can be there at the distribution station. It can be forgotten by people if they have to fly the country, because you cannot do anything with it. So that is what we did. We're currently trying to find funding with the Red Cross to do a pilot. If you know how to get us funding, talk with Van Sander. And also, we're working on several other extensions to kind of extend the functionality to other small tasks that they also do during aid distribution without actually increasing the risk in the system. And this is kind of one of the examples we had, but you may also be familiar with the contact tracing apps. Back in 2020, if you remember, there was a pandemic, it was COVID, we couldn't see each other, that's a whole mess. And one of the important things that we needed to solve in order to go back to normality was to cut the chains of infection. COVID was spreading too fast, and traditional contact tracing was not working. And people wanted to put technology. And this was a very critical moment, because at the stage where citizens are at home and are in a very stressed situation, they could accept any technology that you give them as long as they can go back to normal life. So it was very important to make sure that the technology that we would put in there would actually not create further damage. And that's what we did. And I had the privilege of leading a group of researchers in many institutions across Europe, working with governments, in particular a lot with the Swiss government, and also with Google and Apple to create a protocol that would allow us to break these chains of infection without infringing any privacy. And I'm not going to bore you with how this works. You already had more crypto than you ever wanted in your lives. But the goal here is that during that time, you probably had heard me to talk a lot about privacy and privacy and privacy, because privacy was the good kind of marketing term at that point that would actually make people believe that this is what they wanted. But the real thing that we did is that we created a system in which the only thing that moves around are random numbers. Random numbers that are not connected to identities, to location, to social context, to nothing. And that means that the whole system only creates stuff that is good for nothing. Again, we could have this system, the central system, in a cloud, in the middle of the Swiss government, and nobody should be scared or afraid. It's not a problem if it gets hacked. It's not a problem if nothing happens, because the system is created by design to not be good for anything that is not notifying other users about the fact that they have been close to a contact. This was the biggest success of my career. It was implemented by Google and Apple. It was deployed in more than 40 countries. We not only did the design, we also worked a lot in implementers here in Switzerland to work on the code and make sure that the code was also secure. Our code was used by other 7 countries in Europe. But we did more things, like people know a lot about this first line, but actually we spent the whole year doing a lot of privacy engineering to solve other small problems that were in the system. And we were able, for instance, to push network privacy defenses that would make sure that the traffic of your app, when it communicated with the server, would not leak any information about you or your health status that were never seen in the market. Like, nobody had ever seen this before. Nobody had cared about privacy enough to push this thing. And thanks to us pushing it, well, Switzerland did it, Spain also used our system. We pushed other countries to do the same thing and to protect. They didn't do such a good job. We did a lot of work with them to improve the system in Germany, the system in Italian. We found problems in other systems, including Google's. And we're not very good at doing this, to be fair. And the things that I'm most proud of, I mean, these things were cool. They were actually cool. They were a lot of fun from a technical perspective. But the thing that really was kind of, I think, the big contribution is that we pushed for a new way of doing things. our effort to actually not only talk about this very openly, but just be very open, right? We went very hard on creating very fast a GitHub repo that was open and that everybody see our design process kind of by the millimeter. Actually pushed countries, all countries in Europe, nobody could actually have an app in their country without having it open. And this had never happened before, right? And it created a new way of doing things. And then we also pushed this idea of decentralization, the idea that you don't collect data on a place because then you cannot control it, as kind of the way in which we build systems, especially when we build them from the government for citizens. And when the COVID passport came, you remember 2020, 2021, and then there was this new hoo-ha about we need another app that has COVID passports. And at that point, nobody even thought, like it was not even on the table, the idea that you would just kind of have a central server that would check everything, which 2 years before would have probably be the first solution that everybody thought about. And thanks to all of our effort, kind of is the idea that this is not something that can happen in the world. And hopefully it's nothing that will ever happen again. And this last, before I let you go to the Apero, we also worked with the investigative consortium of, the International Consortium of Investigative Journalists. If you don't know these guys, they are the guys behind the Panama Papers, the Pandora Papers, the FinCEN files, the Luxembourg leaks. They are the guys that make all of these investigations to show to us, well, where things go wrong. And they are very important. They are very important because they held accountable all these elites that kind of govern us and are doing a lot of shady deals in the background. And they are extremely important to keep our democracy and our kind of society healthy because they are sometimes the only barrier between kind of the corruption and us. And for them, like for the Red Cross or when we were doing the contact tracing apps, digitalization was both a problem and an opportunity. It was a problem because suddenly, instead of having a trove of documents, right, on paper that they could actually put Post-its on and kind of underline and study very easily, they suddenly had a USB stick with 20 terabytes of documents. And tell me how you put Post-its on different documents on your terabyte, right? This is very hard. So they solved this problem on their own by creating an open source tool based on open source tools that actually would process all of these documents and find what they call name entities, companies, names of people, and places that would allow them to browse these documents and these whole collections in an easier way. And once they had this thing, they said, but wow, now we have all of this digitalized. What if, instead of only searching on my collection, I actually can search in all the journalist collections? That would be great, because there is actually a lot of information in other people's collection that's out. I don't know if you realize that there's not that many rich people, and that they're connected with each other. And also, surprise, all of these scandals that they put in the previous slide, a lot of names are the same. So when you're investigating something, typically you have also information that is useful for another journalist. And again, the question is, how do we do this without increasing the risk? How do we do it without now putting all of this very sensitive information out in the wild for people to just look into it? And just to give you an impression of how important this is, well, there is this guy, probably you know him, Edward Snowden, that did one of these leaks and now lives in Russia, right? So it is not a joke to have some of this information, so it's very important for them to have it hidden. We work again for almost 2 years with them to create a system in which we use, again, a lot of cryptography. We created new cryptographic primitives. We created new systems to do anonymous messaging to create a message in a system in which they can search in the network without revealing what they're querying for, which actually also reveals a lot, right? If you query for one of these keywords like XK's core or the muscular program, these kind of things that only appeared on the Snowden revelations, you actually know that those exist, which can put you at risk. Not revealing their collections, not revealing what they have, and even not revealing their identities, unless they actually want to do so. And this way, we allow them to move to a digital world and kind of leverage all of the power without increasing the risk. They can do the same investigations they had before without, with much more power, but without changing the risk level. And getting to an end, if I would like you to take something home, is that privacy that we always talk about, we want to have privacy, It's not a goal. It has never been a goal. It's the means we have to protect ourselves and our society. And privacy engineering must be about implementing this protection. If we do privacy, but we don't protect from interference, then actually we have done nothing. And there is a lot of technologies, these privacy-enhancing technologies that enable you to limit purposes and create very cool systems while minimizing the harm that they can make. We are at a crucial moment in life in which we are shaping the future, our future and the future of our children. And it will be digital. Digitalization is super powerful. But already in the past, there are many times which we have decided that maybe moving fast or moving very far is not desirable. In medicine, in aviation, in automotion, not always better is actually worth it. We need to make it safe. And me and the group are here to try to create the technologies that will enable us to build the future in which I really like to live on. And these are actually the people that will do all the work. I'm just here just to tell the story. So big applause for them, and thank you very much for listening. I don't know what happens now.
Slide and go to Q&A.
Okay. So if you have questions, I'm happy to take them.
Thank you very much. Very nice talk. I had a question about the first example you gave with Red Cross. I was wondering with this system if it would be possible to change easily sometimes the purpose. Like for instance, let's take like the case where recipients are not entitled, the entitlement is changed for them. Mm-hmm. How can you do that with such a system? Is it possible?
Yeah. So the question is, the system evolves, right? People change their needs change. People have children, people die, people get married and leave home. What do we do? Indeed, I presented here the very kind of basic form of you have those things. But we have a whole process in which if you need to evolve, you take your car to the registration station, and then you can change actually the values that are inside. Indeed, this has to happen inside a trusted environment, and you can only do it within the Red Cross time. But you can do this without the Red Cross actually learning your key. They just change what would be your entitlement. And we use very similar things for revocation and for other things that I didn't explain today, but are basic for the system to actually be functional.
Thank you very much. I was wondering how to raise awareness among the community about this research and that these solutions really exist, because people are stuck with what's existing, and even like the work you did in COVID. So I remember there was a collaboration that was in a wider sense, but at the end they did not implement actually the most secure privacy-preserving one, right? So how can we reach to the society about our research so that that can enforce the legalization as a scientific community? Because usually we are doing this at a level that is not easy to communicate to the society. So what are your ideas about this? Because, yeah, that's important for me as well.
So the question is, how can we make people aware, A, of the problem and B, of the solution? There are two things. Well, one is to work on solutions and make sure that we have this thing and we don't do a one-off, right? And here I presented here 3 projects, and in our lab we work a lot on trying to demonstrate that this is not kind of a one thing. We actually can do it for a wide range of purposes. But the second question is, how do we get people to know? Well, you need to go to the people. People will not come to university. People will come to the Privacy Enhancing Technology Symposium. No, okay? So I do a lot of work. For instance, I go to talk to policymakers. I go to talk to journalists. I go and talk with NGOs. And it is many times for scientists about getting out of your comfort zone. It's very easy to go and present your latest work on whatever, this conference where everybody's going to be, oh, what is your crypto thing? But it's hard to go out of your comfort zone to go to these people. And it's also hard because it doesn't count a lot in your tenure file. My tenure file doesn't count a lot how many times I went and talked in Geneva to people, the events I go to talk to journalists, to They don't care, right? They only care when 6 months later, actually from this came out a collaboration that came. So it is a little bit of a choice, and sometimes it's a bit more of a risky choice, but it's the only way I know is to really go out there. What I also have to say is that it works, and then at the end, it does count, right? It does count, and my work here is valued, including all of those sides, and at the end, well, it's also something that the university values, the fact that I'm known and I go out there. But it is a lot, and it is a lot of time to also find how to talk to those people, because you cannot go and tell them, here is my crypto algorithm. You need to find what is the language, what is the way, what makes them tick, what is the thing that's going to make them kind of understand that this is the way. And that, well, is not always in your super straight academic path, but if we don't do it, then we will lose.
Hello, thanks Carmela for the talk. I was wondering, you said that minimization doesn't work, it's a bad metaphor, and then talking about the best metaphor of the purpose limitation. Do you think there are areas, domains, where it's not possible to limit the purpose, and perhaps where either we should just not go at all and never do anything in these domains, or perhaps fall back on the other sort of metaphors?
So, I mean, it is true that it builds on each other. It's not that it's not a good metaphor, it's just not sufficient. It's not sufficient to tell people how to build something that actually will create the protection. And I also said, yeah, it is true. There are some fields and there are some applications in which it's very hard to minimize the possibility of harm, because the application itself will require data that you need, and they will require data that can be used for many purposes. But I still think that the way of designing in this direction kind of makes that very explicit. When we focus on the data minimization, we just kind of hide the data and we're like, oh, our thing is done. And we don't think about the harm that can happen. When we go on the purpose limitation, then we will actually have to think about all of the purposes and harms we're enabling. And then maybe we make the decision of not going there. And in my opinion, sometimes we should not go there. Or maybe in other cases, also in my opinion, we should go there. Sometimes the risk is worth it, right? And in the case of medicine, not all medicines are perfect. Not all, yeah, some of them, they always have something, they have allergics, they can create some harm, but we have created as a society kind of a threshold where we think that that is enough. Or like in the case of the COVID vaccine, we decided where we don't know exactly, but the risk now is, the benefit is worth the risk, and other times it's not. But we need to be able to elicit the risk. We need to be able to have it explicit. And I believe that only going in this path, we can make that clearer, also for society to decide. Because if we just tell people, oh, we won't have the data, it is very cool, hello Google, yeah? Google Sandbox, Apple, whatever is the name of the thing. Yeah, people will be, oh, they don't have my data. But that doesn't mean anything. So we need to move, and we need to push also companies to talk in a different way about what they're doing, so that we can make better decisions about where technology should go. He wants the Apple.